All right, welcome to section 9.11, in which we are going to solve any quadratic function or formula by the quadratic formula. The quadratic formula will work as a solution technique for any quadratic equation or function we can come across. In fact, almost every real world, the vast majority, I think 98% of all real world applications of quadratics can be solved by the quadratic, or can only be solved by use of the quadratic formula. So we're going to look at that today. Our quadratic formula, first of all, we're going to look at our quadratic in standard form, which is ax squared plus bx plus c is equal to 0. And the quadratic formula is given by x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you can probably go online and find a bunch of little songs to remember this by, but this is the quadratic formula. And really, it just requires us to identify our a, b, and c values from our standard form of our quadratic and plug into this equation. It will also cause us to go through and simplify some of our radicals and rationalize them. Our steps for solving the quadratic formula is we're going to write the quadratic equation in standard form. We're going to identify our values of a, b, and c. We're going to plug those values into the quadratic formula. We're going to simplify the inside of the radical first. And that's also known as the discriminant. And we're going to follow the correct order of operations to simplify. Now, before we start solving using the quadratic formula, as I've just shown it, let's take a quick second to remember about our quadratic equations and how many solutions they can have. A quadratic equation could have two solutions, one x-intercept and a second x-intercept. They can have one intercept, or one solution. This is where the x-intercept and the vertex are the same. And there's a case where we have no solutions. That is when there are no x-intercepts. With that in mind, let's talk about the part of the quadratic formula under the radical sign known as the discriminant. The discriminant comes from the quadratic formula, and the discriminant is b squared minus 4ac. It's the part under the radical in the quadratic formula, and it tells you how many solutions you'll have. If our discriminant is a positive number, then there are two real solutions. After all, you're going to get plus or minus the square root of some number q. We'll call it actually d. This will be easier. And if that's positive, you'll get a positive square root and a negative square root. Two solutions. If it's equal to 0, then there will only be one solution. If you think about it, this would be the case of plus or minus the square root of 0. Well, that's just equal to 0, and therefore you'd have minus b over 2a as your discriminant. And finally, there's a case where you'd have a negative number. Then there are no solutions, because after all, negative square roots are no good. So let's go ahead and detect how many solutions a specific quadratic might have. X squared plus 6x plus 9. So we're going to identify our a value, which is 1. Our b value, which is 6. And finally, our c value, which is 9. Now we can plug this into the discriminant. Now, just writing it out, I'm going to put parentheses around every number I substitute in for every variable. So 6 I will put in parentheses for b. And then I'll subtract 4 times a times c, which in this case is 1 and 9 respectively. To do this, I can go to my calculator to calculate my discriminant relatively easy. To do this, I'm going to put again 6, my b value in parentheses, square it, and subtract 4 times my value of A times my value of C, all those in parentheses, and I come up with a discriminant of 0. Therefore, I have one real solution. If I were to graph this, I can see this very clearly. Putting my original equation into my calculator and graphing it, I see I have one real solution, and the vertex is also the x-intercept. I can prove that on my graph as my table as well. I see my vertex there is at -3, 0, and it is also my x-intercept. I can find the discriminant for this next equation, x squared plus x minus 56. I first need to identify my A, B, and C values. I don't see a leading coefficient, so it's 1. So A is 1. My B value is plus x, so my B term is plus x, so my value for B is 1, coefficient on x there, and my C value is -56. By the way, that means I have a y-intercept at 0, -56. I'm going to go ahead and plug this into my calculator. I'm going to type it in just like so. Everything I substitute in, I put parentheses around. It makes sure that I won't make any errors. I hit enter, and I see that my discriminant is 225. 225 is greater than 0. Therefore, I should have two solutions. Of course, I can verify this with my calculator. I'm going to have x squared plus x minus 56 is my equation. I put it in the calculator, and I go ahead and graph this. And I clearly see two x-intercepts, so therefore two solutions. Finally, for a third example, again, to find my discriminant, I will take my A, B, and C values and find them. My A value, again, is 1 here. I have x squared as my first term. The coefficient on it is 1. My B value here is the coefficient on x, which is 3. And my C value is this plus 8 here, the constant at the very end. Therefore, I'm going to put this into my calculator. I put 3, which is my B value, I square it, and I subtract 4 times my A value of 1 times my C value of 8. And I've already noticed that this is probably going to be negative. And when I hit enter, I see that I have a discriminant of -23. Therefore, I have no real solutions, and therefore no x-intercepts. And I can see this when I go to my calculator. I plug the formula into my equation, or the equation into my calculator, sorry, and I graph it, and voila, no x-intercept. Therefore, no solutions. So we're going to solve the following using the quadratic formula. So we have x squared minus 4x plus 3 is equal to 0. Again, we have to set it equal to 0 in order to solve this. And the first thing we're going to do is that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So let's identify our a value. And our a value here we see is the leading coefficient of 1. Our b value is -4. And our c value is 3. So what we're first going to evaluate, and when to solve this, we're first going to evaluate b squared minus 4ac. This is known as our discriminant. And it's important that we go through and we calculate this first. Our b value is negative, so whenever we substitute something in, we want to substitute a negative in parentheses. So we're going to take the quantity of -4 squared minus 4 times our a value of 1 and our c value of 3. When we get that, we will then go to our calculator and use our calculator to do some of our calculations. I'm going to go ahead and enter that into the calculator right now. -4 in parentheses quantity squared minus 4 times A times C. And I find that my discriminant is equal to 4. Now, when our discriminant is greater than 0, we'll have two real solutions. That is, two x-intercepts. From there, I'm going to go ahead and complete the rest of my quadratic formula. So I will have x is equal to negative b plus or minus the square root of 4. Okay. Again, this is our discriminant. So our square root of 4 all over 2 times a, which is going to be negative, and I'm going to put my b value in parentheses. So I'm going to have a negative of negative 4 plus or minus the square root of 4 all over 2 multiplied by 1. I can then go ahead and enter this into my calculator. Now, this tells me I have two solutions. This will give me two solutions, okay? Now, before I go put it in my calculator, one other thing I'm going to do is I see that I have two double negatives here. So that becomes positive. And I will end up with a positive 4 plus or minus, well, the square root of 4 is equal to 2. So 4 plus or minus 2 all over 2. We've said it will give me two solutions. So I will have one solution, which is 4 plus 2 all over 2. That'll be one of my solutions, which will give me 6 over 2, which is equal to 3. My other solution will be 4 minus 2 all over 2. Which means I will get 2 over 2, which is equal to 1. So my solutions here are x is equal to 3, or x is equal to 1. Or I could even say 3, 0, 1, 0. Since both of these solutions are whole numbers, they're very easy to check. I can go to my calculator here. I plug my equation into my calculator, and I can go to second graph to trace it, or to second graph to find my table. And I notice at 1, 0, I have an x-intercept, and I also have an x-intercept at 3, 0, which are both our solutions for our problem. So we've calculated this correctly. Example number 2. We're going to solve again using the quadratic formula. X squared plus 4x plus 1 is equal to 0. Our first step here is to identify our a value. Our leading coefficient is 1. Our b value is positive 4. And our c value is positive 1. The first thing we're going to do is work with our discriminant here, that which is under the radical sign. So we're going to solve for b squared minus 4ac. Again, we're going to plug our b value in. It's 4 quantity squared. 4 squared minus 4 times our a value times our c value. A is 1. C is 1. I will then go ahead and type this into the discriminant into my calculator. 4 squared minus 4 times the a value times my c value. When I do this, I get a discriminant that is equal to 12. Which means I will have two real solutions for two x-intercepts. Knowing that my discriminant is 12, I can then plug everything into my quadratic formula. X is equal to negative b. Notice I'm putting my b in as a negative value. I'm putting my b in parentheses. Plus or minus the square root of 12 over 2 times a. Again, I expect that my two solutions, the fact that I have two real solutions, comes from here, the plus or minus. This will give me negative 4 plus or minus the square root of 12 over 2. Now, the tricky part is 12 is not a perfect square. So we can't really come up with a whole number, so we're going to end up with a radical answer. But I do know that one of the factors of 12 is 4. And 12 can be factored to 4 times 3. And 4 is a perfect square. So I can say that my answer, x, is equal to negative 4 plus or minus the square root of 4 times the square root of 3 all over 2. Which means my answer then becomes negative 4 plus or minus 2 radical 3 over 2. Knowing that I'm going to have two solutions, x again is equal to negative 4 plus 2 radical 3 over 2, or x is equal to negative 4 minus 2 radical 3 over 2. My 2's will cancel out, and the 2 will also cancel out the negative 4 to becoming negative 2. And we'll do the same over here. 2 cancels out both 2's. The 2's reduce 4 by 2. And what I end up with is x is equal to negative 2 plus radical 3, or negative 2 minus radical 3. These are known as our radical answers. I can also come up with decimal answers. Okay? And how am I going to do that? I'm going to go to my calculator. And I'm simply going to type in both of my answers. Negative 2 plus radical 3, that's going to be second x squared. Enter. Or negative 2 minus radical 3. Second x squared will give me the radical sign. Oops, a little too many buttons there. That sometimes happens. The 3 under there. And I find out my answers are either negative 0.26 or negative 3.73. Those, of course, would be my decimal answers. So I'm going to get an answer that's in radical form or in decimal form. I could go through and check my answers here. And how could I do that? We'll go to and enter in our equation in a moment. I have my equation entered here. Now I know these are not whole numbers, so to go to second table, or second graph to show it on the table, they're not going to appear. But I can do second trace value. And I can enter my expression. Negative 2 plus second x squared, radical 3. And and I see that my y value is 0. I can do the same again, second trace, value, enter it in for -2 minus radical 3, and I end up at -3.73 is equal to 0. So I've proven this works. All right, finally we come to an example where we have a leading coefficient that is not 1. So in this case, our a value is 2. Our b value, the coefficient on x, is 3. And our c value is -5. Our first task, of course, is to find our discriminant, bx squared minus 4ac. That, in this case, is going to be 3 squared minus 4 times our a value of 2 times our c value of -5. This value is entered into my calculator as 3 squared minus 4 times 2 times -5, with parentheses around all values I'm substituting in, and I get a value of 49. I can then substitute that value, which is my discriminant, into my quadratic formula. So x will be equal to -b, and b value being 3 here, plus or minus the square root of 49 over 2 times 2. Again, since my discriminant was 49, that means I'll have 2 real solutions. I see that 49 is a perfect square. And so my answers will break down to x is equal to -3 plus or minus 7 over 4, which I can then split up into both the plus and minus version. -3 plus 7 over 4 will give me 4 over 4, which is equal to 1. On the other hand, I'm going to have -3 minus 7 over 4. And since I'm using a lot of negatives, I can also use my calculator to calculate. Wisely plugging this part of the equation, the answer, into my calculator as -3 minus 7 over 4, I end up with -5/2 as my other answer, which means my solutions are x is equal to 1 or x is equal to -5/2, which of course I can check in my calculator. I can plug this into my calculator. I can go to the table to find my x-intercept. Table. See, I do have two solutions. I find one of my values at 1, 0, but I know I have -5/2 as my other solution. So I have to go to second trace, value, and I can enter in -5 divided by 2. That's also known as -5/2. And I come up with y equals 0. So I know that -5/2 is also a solution. All right, looking at this example, the common mistake is this. People will start identifying my a value correctly as 2. And from this point, things get hairy. People will say, oh, well, that's my b value, and this is my c value. And this would be incorrect because this is not in standard form. So none of this is right. So I have to get these values into standard form. So we're going to redo this and erase all this, and we are going to rewrite this in standard form. So 2x squared is equal to 8x minus 7, which means I need to move these terms over to here. In order for me to do that, I need to subtract 8x from both sides. That will give me 2x squared minus 8x. is equal to negative 7. And then I'm going to add 7 to both sides. To get 2x squared minus 8x plus 7 is equal to 0. Standard form. From here, my a value is still 2. My b value is negative 8. And my c value is 7. From here, I calculate my discriminant. My discriminant is just negative b, or is positive b squared minus 4 times a times c, where a is 2 and c is 7. The easiest way to calculate that is put that in my calculator. I put this into my calculator and I get negative 8 squared minus 4 times 2 times 7. Again, I cannot stress it enough. I put all my substituted values in parentheses. I hit enter, and my discriminant is equal to 8. Which means I will have 2 real solutions. Now, 8 is not a perfect square, so when I create my quadratic formula, I have negative of b, where b is negative 8, plus or minus the square root of 8, my discriminant, over 2 times the value of a, which is 2. This, of course, will become positive. 8 can be factored into the perfect square 4 times 2. That is a perfect square, which is great. That's going to help us simplify radical 8. So x is going to be equal to plus 8 plus or minus the square root of 4. So I write down the square root of 2 instead. The square root of 4 times the square root of 2 all over 4, which is simply going to be 8 plus or minus, well, we all know that the square root of 4 is just 2. Radical 2 over 4. I can then factor out a 2 on the top, which would give me 2 times 4 plus radical 2. I just factored out a 2 over 2, over 4. This allows me to cancel some things out. And I can get as my answers in radical form, x is equal to 4 plus radical 2 over 2, or 4 minus rad 2 over 2. These are my radical forms. And then I can also get my decimal answers by plugging those into my calculator. Plugging these into my calculators, I see 4 plus radical 2 over 2 is 2.71, rounded of course, and 4 minus radical 2 over 2 is 1.29. So my x values are x equals 2.71, or x is equal to 1.29. Those would be my decimal answers. One more example to go. But before we get that example, I should check my answer as always. For our final example, we see that this is also not in standard form. As we know, standard form is always ax squared plus bx plus c, and to solve, we must be equal to 0. So we need to move our 2x over. So we can simply subtract 2x from both sides. To do that, I end up with 0 is equal to x squared minus 2x minus 4. Again, I can't combine the negative 2x with any of those other terms. They are unlike terms. So my leading coefficient is 1. Therefore, my a value is 1. My b value is negative 2. And my c value is negative 4. Which means I'm going to solve for my discriminant of b squared minus 4ac, which is just my b term squared. Negative 2 quantity squared minus 4 times a multiplied by c, which is negative 4. Plugging this into my equation, or my quadratic, or the discriminant, negative 2 in parentheses squared minus 4 times 1 times negative 4 in parentheses gives me a discriminant value of 20. Which means, again, I have two real solutions. Therefore, as I solve, I have x is equal to negative b, my b value here being negative 2, plus or minus the square root of 20, which is not a perfect square, all over 2 times 1. Which means I'm going to get, well, a negative times a negative becomes a positive. So I'm going to get positive 2 plus or minus the square root of 20 over 2. Now, if I remember, 20 has a perfect square as one of its factors of 4 times 5. So again, I can rewrite this solution as x is equal to 2 plus or minus the square root of 4 times the square root of 5 all over 2, which means I get 2 plus or minus, well, the square root of 4, again, as we've examined, is 2. So I get 2 plus or minus 2 radical 5 all over 2. My 2's in the numerator cancel out with the 2 in the denominator. And I end up with 1 plus or minus radical 5. So my radical solutions are x is equal to 1 plus radical 5 or 1 minus radical 5. And my x values for decimals, well, I'll need to put that in my calculator. And when I put this into my calculator, I get my values of 3.24 and negative 1.24. Again, my radical answers and my decimal. All right, that is today's lesson. Please go ahead and start on your 9.11 or 9.11 worksheet. Well, I said 9.11, but 9.11 worksheet. And remember, what do baby parabolas drink? Quadratic formula.